Welcome back to my channel. Those who watch my channel must have been wondering uh, what happened to Prasad. He is not posting any videos anymore. But then, as I told you, the purpose of this channel is to learn maths and physics necessary to understand relativity. The ultimate aim being uh, learning relativity and thereby, if possible, come up with our own theory, for example. So, when I was reading the Principle of Relativity by Dr. Satyendranath Bose, which I read for you in the last video, when we came to one certain point where Einstein explains, says that imagine a light ray originating from the origin, and it's a spherical wave, he says. Spherical wave, let's say, this is the x-axis, this is y-axis, and there is the z-axis or whatever. And then, if you take a point here, point on a sphere, then if you drop perpendicular to both axes, this will be, of course, y. This will be x, right? That is the distance, right? So this will be root of x squared plus y squared, right? And then what he says is, I'm not just, I'm just explaining how we get the spherical wave. Here, this axis, there is an axis here quite similar to z. That is normal to these two axes. This axis and this axis, this is a normal pointing towards Euclid side. So, if you connect the origin to this point, say P, X, Y, Z, you take, then what happens? This will be, this is rectangle, right? This was rectangle, this was rectangle, this is rectangle, and now what happens? This, if you take this, the hypotenuse of the next rectangle, what happens? X squared, this distance will be given by root x squared plus y squared plus z squared, right? So that is basically the radius. This is nothing but radius of the area. He asks us to imagine a rigid sphere from whose origin the ray emanated, right? Like it passes through all the 3 points, let's say. So there I got confused in the sense, why a spherical wave? Because we are dealing with, this is three-dimensional uh, scenario, and in here what this radius is equal to root of x squared plus y squared plus z squared. So, and in the same, what do you call, the invariance of, if you speak in terms of space integral, you all know this light cone, where ds squared is equal to c t c c square d square ds is greater than c square d square, ds is less than c square d square. This is light-like. This is time-like. This is space-like regions. Right? This is basically the light cone. So talking about this, he says the invariant space integral d squared is given by yeah d squared. The distance between any 2 points, let's say between x, y, z, t, that is four-dimensional space, and x plus dx, y plus dy, z plus dz, t plus dz, sorry, dz, dz, dt, yeah, dt. So this space will be given by g11 dx squared plus g22 dy squared plus g33 dz squared plus g44 dt squared plus 2g12 dx dy plus 2g13 dx dz plus 2g14 dx dt plus 2g23 dy dz plus 2g24 dy dt plus 2g34 dz dt. In fact, there are 1, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 terms in all together. He says there are 10 terms altogether. This is the invariant space interval. Okay? So when I looked at this, I looked at the sphere, spherical, the radius of sphere, then I got an old idea that I used to for a long time, in fact, for 15 years or so. I have been harboring this idea, and it came back. Why should we take only what do you call uh, spherical distance, spherical distance, and only d squared? Why not we take d s cube? Why not cube? Why only square? That's what that's the doubt I got, and thus it got me thinking, and I came up with a what do you call uh, rather unconventional idea. Let's say when the Big Bang started, let's say, uh, it was more or less like a very thick, very dense sphere, and this sphere exploded and kind of like it took the shape of kind of a cube. This was spherical, right? That was the first of the Big Bang occurred, and the light. This is more like cubical in the sense there are, in fact, curved spaces versus flat, straight spaces. They were both. So right now this is expanding, but after some time it will again form another what do you call that? The uh, uh, what do we call it? The where it the black hole, black hole, and that black hole, the dense uh, matter, which reaches certain density. After reaching certain density, it will again form the state space. That's the idea I always used to have, and then I came up with my own theory. My own theory, in the sense, there is nothing more inspiring than nature, and nature is all numbers. Nature is built up of numbers, and these numbers, we have a very interesting pattern about numbers. Let us say, let us take, let us say, uh, rather one building like that. So the diagonal, let us take like this. This is one, which is 2, that's it. This is 3. If you take 1 cube plus 2 cube, that gives you 3 square, which is 3 square. This is 1 cube, 2 cube, right? And then there is another uh, uh, triangle that we can build here. This is 3 square, this is 4 square, this is 5 square, right? So what I from the beginning I used to have this idea that the uh, the whole nature is built up, the space is built up of numbers. You can represent them numerically. You see, you can get uh, from algebra you can get geometry. From geometry you can get algebra. So I generally people come from take geometry and from geometry they work out algebra, math. But I took the reverse way, algebra to geometry, in the sense I took the primary numbers, natural numbers, and summed them up and found the relation between them. Now, second one is 3 square plus 4 square equal to 5 square. And above this, there is one more triangle we'll come up with. 3 cube, 3 cube, 4 cube, 5 cube. In this case, it is not actually the Pythagorean theorem, 3D Pythagorean theorem. This because the sum of these three, these two, square root of sum of these two doesn't give 5 cube, right? So this is rather odd, and the relation we have here is 3 cube plus 4 cube plus 5 cube is equal to 6. So I thought there is definitely something, some uh, indicator in this uh, um, what do you call um, math between natural numbers, first natural numbers, especially first 6 natural numbers. So it has a lot to do with our what do you call this is the spherical uh, space, and this is the cubical space. If you can find some correlation between these two, right, mathematically, that is, if you can somehow come up with a intermediate space which includes both, which includes both the spherical world and the cubical world, then I think we can achieve unification. Unification of course, our fundamental forces. That is the basic conundrum, as we can call it, facing the unification problem. So we can come up with a system where the cubical invariance dsq is given by x cube plus y cube plus z cube plus t cube well, at all. There will be kind of, if you want, I can write it down, but yeah, let me write it down because that's not a big deal. This is nothing but, yeah, 1 second, pdx tq plus 3d px squared y plus 3xy squared plus 3dx squared 3dx squared 3x squared z plus 6xyz plus 3 3y squared z plus 3t x squared plus 6t xy plus 3d t 2t y plus 3 dx dz squared z squared x z squared x z squared plus 3y z squared plus 3t x 2t squared x plus 3 t. You may be wondering what I am going on with 3t square z plus 6 txz plus 6ty z. This is the total expanded form of this Vs cube if you take cubical invariance. How many terms are there? 1, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 15, 16, 17, 18, 19, one term, somewhere one term, because they make, yeah. So there are 20 terms actually. So my suggestion is that instead of taking the square invariance, we will take cubical invariance. In that case, what happens is if you take cubical invariance, what happens is uh, the cubes are also involved. As I told you, the biggest problem here is from 1, 2, 3, 1, 2, 1, 2, 2 cube, 3, 3 square, make 3 square, 3 square, 3 square, 4 square, make 5 square, 3 cube, 4 cube, 5 cube, make 6 cube, but not according to Pythagoras. So, if you can club all these three, this is more like that, this is more like relativity of 4 by 4 matrix, this is more like that. So my conviction, strong conviction, and of course the Lorentz factor will now be cube root of 1 minus v by c whole cube. Here we had square. Lorentz gave originally gave square here instead of 3. But in the cubic invariance, we'll have 3. So that's a basic concept I came up with because it has everything to do with spherical becoming cubical, this interchange between spherical and cubical spaces is what that if you can achieve, put them together, you can achieve unification. Any unification process, successful unification process, should include both spherical space and cubical space. How we can achieve that? Simply taking the powers. Let's say, in terms of speed of light, if you take speed of light is c, let's say there is c squared and c cubed. Uh, if you combine these three, you will get, in the sense, not exactly combine. If you combine powers of these three, you will get c raised to 6. That is basically somehow uh, what do you call scalar multiplication. You take 6 c raised to 6. If this c raised to 6 is c cube raised to squared 2 or c squared raised to 3. That is, this is both square and cube. In the sense, this can be converted, the parts of 6 c raised to 6 can be either exist in the form of a cube or a sphere. So this is the combination. Minimum denominator for 2 and 3, minimum denominator of 2 and 3 is equal to 6. So if you take c raised to 6, you will get, you can include both. That's my opinion. And then what went wrong? What went wrong? I'll tell you. I have so far discussed about the cubical invariance, right? Now we will talk about what do you we call the Minkowski space. Minkowski space, the Minkowski space, as we all know, the Minkowski space. There are here you have three space-like dimensions. Here you have one time-like dimension. all these three space-like dimensions will be moving along with time, making space-time continue. Right? So here to represent this, to represent special relativity in special relativity, or rather in the relativity, Einstein took 4 by 4 matrix. So these are the 4 dimensions he included in this. Something like the mu equal to 8 by g by c equals to 4 t mu. The in the matrix form. See, he writes this is 4 by 4. I am giving. But what I suppose, what I propose is that this 4 by 4 is not enough. This 4 by 4 is only 2-dimensional. It is covering all the space, but what we need is the 4 by 4 by 4 is equal to, as I'm not sure about this, but 12 pi by c raised to 6 in mu 4 by 4. 4. Then what happens is there will be another meaning. This literal meaning of this is that relativity is not absolute. Relativity is itself, meaning, I'll show you in the next diagram. So, yeah, 4 by 4, if you take 4 by 4 matrix, you will be missing the sixth dimension in the sense. That is why I came up with a thought space which will have something like that, in the sense, like that. So it's going to be okay. So this is gut, this is relativity, spherical, which will have spherical invariance. This will be the term. This term is 6 cube. 6 cube in the sense is equal to 3 cube plus 4 cube plus 5 cube. Rather, as I told you, this is the super time. So what does this mean? This gut which is following 3 square, 4 square, 5 square, 5 cube, and that level comes up like 1 cube, 2 cube, 2. Okay, becomes smaller. Anyway, so 1 cube, 2 cube make 3 square, 3 square, 4 square make 5 square. So this 4 square is what is the third dimension or the fourth dimension time. That was the fourth dimension. They took as 4 by 4. And this fourth dimension doesn't include this 5 cube, leave alone 5 cube, 6 cube. So this 6 cube involves all the three worlds and becomes a 6 cube. And this 6 dimensional 6 space like dimensions along with super time t, let's say, they make the actually 7 dimensional space, which I call space. But if you missed something here, you see, first of all, we had x, y. This is root x squared plus y squared. And then we took another dimension here. This became root x squared plus y squared plus z squared. If you somehow can cube it, if you take a cube of this, then it will represent this part. If you take this part, the other two are easy. The other two are cubes, which is, of course, the ultimate. That will give you the s cube equal to x cube. That is, the cubical invariance will become 6. The 6 cube represents the cubical invariance, and in equation form will be x cube plus y cube plus z cube. If you take only ds, then it will be cube root of this. So ds cube will be given by this invariance, if that is so. But how can you make this square root of x squared plus y squared plus z squared cube? That's a comment. If you can somehow solve this, we are there. Amen. So you are taking u cube plus v cube, giving w squared, let's say. You are taking this w squared, rather, so um, we will take a root of this, u cube plus v cube, square root will be w, and this w cube plus x cube plus y cube equal to z cube. This form of equation we can reach, but only when we can do that is you you take one more here, u cube by root 3, and from there you combine again. This will be v cube by v raised to 3 by 2 And if you take these both these and if you take both of these and combine to the the origin, then this will give you actually this part now. But this part is very tricky. For that, what we need to take is this. The only way you can do that is this root of u cube plus v cube. There is a, if you take qubit and then you take u cube. And for that, the only trick is you have to raise this to 3 by 2, v raised to 3 by 2 if you take. Then you take one more. This will give you u cube plus v cube plus u cube plus v cube. There's a kind of what do you call equation you will obtain. Meaning the trick is to raise the u to 3 by 2, v to 3 by 2. Only then you can come up with the sum. Just like similar, the logic is same everywhere. The same Pythagorean theorem is used. So as I told you, the main point is this Poisson space is which is cubical, right? This is the time. This is going along. This is the super space time, consisting of 7 dimensions. One time like 6 space time. So I explained this whole thing in my book. I wrote a book by name Prasad Space. You can find this in Amazon on Amazon. Kindle publication. You can as well, whoever is interested, you can as well go there and search for Prasad Space. And of course, you all know my name is by Prasad Vemulathalli. Okay, search by this. I will leave links to the Amazon Kindle versions. If you are interested in this series, then you can go there and check my logic there. And apart from that, I have also one more thing to discuss. That which is nothing but the Pascal's triangle. That's my favorite subject. All my life, I spend most of the time in thinking about Pascal's triangle. I assure you, it is a treasure trove of information. Whatever, let it be quantum mechanics, quantum computing, whatever. It all has its roots in, they all have their roots in Pascal standard. Pascal standard is nothing but it gives the binomial coefficients of binomial expansion, and here, if you take Pascal's triangle, these are nothing but powers of 11, 11 square, 11 cube, 11 is 4. And then there's an interesting observation I came up with long back, that is Planck's constant h is given by 6.62 into 10 raised to minus 64 something. This is actually, if you compute this into mass of proton divided by 3 into 10 raised to 8 of the C. This I found long back, and it's very useful observation in the sense, in my opinion, there are the this represents there is a spherical world, this is a quantum world, this is relative world, this 3 into 10 raised to 8 represents quantum, just like when we discussed here 1, 2, 1, 2, 2, 3 squared, 1 cube, 2 cube. Something like this. This represents something like this. And this relative world represents 3 cube plus 4 cube plus 5 cube, 6 cube equal to the cubic one. So this cubic one here, how can we represent that? In the Pascal standard contains everything. Um, yeah, this 190 is more or less equal to 11 square, 120. Right? So here we can associate this with 3 into 10 raised to 4. This next one 2 into 10 raised to 4. This 1 into 10 raised to 2. This is this squares 9 into 10 raised to 16, as we have observed here. This should be, well, the root is root x squared plus y squared plus z squared, the radius. So if you want to get square the radius, then you will get this thing, this thing. Sorry. And then next it will be c cube, that is nothing like 24. If you take like this represents the quantum world. This represents the relative world. This represents the quantum gravity. So going by the same logic, quantum gravity, actually, let's say P, which is instead of 119, 11 raised to 4 into mass of sun, if you take, divide it with 27 into 10 raised to 24, that is, or C cube, then you will get the quantum gravity, in my opinion, meaning it comes to around 1.084 into 10 raised to 9 joules. So this is nothing but the Planck's constant. What Planck constant is for the quantum world, this will hold good for the relative. That's what. So I wrote another book, rather you should call them books, but you should call them booklets, giving all these details. That book is I leave links to my books, um, but of course I will mention it here and leave the links to my books. Whoever is interested, they can go there, check the books. If possible, buy the book. Here, as I told you, first book, my name is Prasad Vemanila Ali. First book is Prasad Space. Second book is Quantum Gravity. Third book is Relativity of Relativity. They were all available on Kindle. I think you can as well read them for free if you have some time. Uh, and then if you feel like buy, like, if you like, buy. Okay? So that I'll conclude my session for today. It's been very long. Uh, yeah, for those who have been wondering what happened to Prasad, where we left him, is just simply disappeared. He made promises and he, he developed cold feet. He might have been thinking, no, I've been thinking, and that spherical wave, simply that spherical wave got me thinking, and I came up with the cubical wave. And as I tell you, it is always the solution to all these problems, you know, will be found in this spherical cube. If you can unify sphere and cube, geometries of sphere and cube, that will give you unification. Some might say it's simply impossible. Then you can. Thank you for watching my video, and we'll meet some other time. Thank you.